Alright, so in this video we're going to pick up where we left off from in the previous video, and now we're going to talk about overriding the implementation of a method that's defined in the base class. We're going to override it in the derived class to specialize or change its functionality. Okay, so to set up this example again, here I have an auto class, and it has an implementation here at the very bottom for a method called start, which is presumably the method that would be required to cause the ignition to fire and for an automobile to start up. But as we're developing our application, we realize that when it comes to trucks, that you have to take a few more things into account before you can start a truck. All right. I admit, this is a cheesy example, but play along with me for the purposes of this example. So thinking back to our situation here, I realize that I have a problem. I need to create a truck start method. So I have two choices, just like I did in the previous video. I can create a second method on truck. So let's go over here to truck, and I could add a second method called truck start. And then just hope that those who actually use my truck class will ignore the start method that I inherit and only use truck start. But I strongly recommend that you never do this. There's a couple of reasons. First of all, you can't rely on the fact that people are going to use one method, your preferred method, rather than a base class implementation of a method. And so they might miss all of the functionality that you added and create an inconsistent state. Okay, in this application, it doesn't really matter, but in a real application, that might be pretty important. So that's the first thing. You can't count on consumers of a class to use one implementation of a method over another. You need to hide or override the original one. So that's the second choice. We'll get to that in a moment. But the other reason that you wouldn't want to do that, to have a start method and a truck start method and then hope that everybody uses the truck start method, will become more readily apparent tomorrow when we talk about polymorphism. Big word. It's an easy concept. Okay, so the second method that I can choose instead of the copy and paste method is to override the base start method like this. So here I am, I'm in truck.cs, and what I want to do is public void start console.writeLine, and we're just going to put in here truck ignition sequence. All right, now let's go to the program.cs class, and I'm going to comment all this out. And actually, let me keep that part. So truck, my truck equals new truck. We're going to steal that from the previous example. And so we're going to go my truck dot start. Okay. So if we were to go back to our truck class, and let's go ahead and just build it. I think that will create. Okay. You can see here that I get a little green squiggly line. It says it hides inherited member understanding00.auto.start. Use the new keyword if hiding was intended. So behind the scenes, what's going on is this. It's a warning that says, really behind the scenes, we're currently hiding the base class implementation, suggesting that we should be using the modifier new. So by all rights, this is what C#, or the C# compiler rather, sees when we wrote this code. All right, it implicitly adds the new in there. So using the new modifier creates a new member with the same name as the modifier in the base class and causes the original member to become hidden. This is not exactly the behavior that I'm looking for. I'm sorry, but again, the reasons for this will become clearer tomorrow when we talk about polymorphism. For now, when you think about overriding a property or method in a base class, you should think of two key words: virtual and override. So I'm going to change the definition of our start method in our derived class to look like this: public override void start. Okay, I'm going to save it, and then I'm going to go up to debug build solution, and I'm going to get an error this time, and it says cannot override the inherited member auto start because it is not marked virtual, abstract, or override. Okay, so first of all, the modifier override extends the implementation for an inherited member. We're going to look at the syntax, and then we're going to talk about the basic difference between the new and the override modifier in the next video. So what the error that we got is saying is that we have to mark the base class's implementation of the start method with abstract or virtual. In this case, we're going to use only the virtual modifier in this video. So back in our auto.cs class, in order to enable this functionality to allow this method to be overridden, what we need to do is this: add the virtual, if I can spell, there we go, public virtual void start. The virtual keyword means that if a derived implementation of this method exists, then use it. So in our case, truck does have an implementation of the start method, so the .NET runtime will use the truck's specialized version of the start method. So let's go ahead and run the application. And so we can see when we call the start method, it's actually calling the truck's implementation, truck ignition sequence. Great. So let's recap. What had just happened? We were able to create a specialized version of a method, or in other words, a version of the start method specific to the peculiarities of our truck class. On the parent class, we defined the method as virtual, meaning that it will acquiesce the implementation of that method to child classes, classes that derive from the auto class. Okay, so what's the ultimate payoff here? Well, there are two reasons why this is important. First, we get to change how the derived class behaves differently than its parent class without throwing out the entire parent's implementation of all the other methods and properties that it offers us by being a specialized version of that class. The second reason why overriding a base class's implementation, again, it's going to have to wait till tomorrow when we talk about polymorphism. Sorry about that. But there is a payoff for this, and we'll see it tomorrow in full bloom. Okay? All right, so the last thing that I want to point out is that in some cases, we may still want to rely on the base class's implementation of a method in addition to our new specialized overridden version of the method. So how can I go back and say, call both my new version of start here in the truck class and call the implementation of start in the base class? And you'll want to do this more than you think you might want to. We'll talk about it later. But how can you do it? What's the syntax for that? Well, we can get to the base class's implementation of anything, whether it be a property or method, using the keyword base. So if I type in base dot, it knows now I'm talking about the truck class's base class. What is that? The auto class. So IntelliSense is smart enough to know, and the C# compiler is smart enough to know, that I'm really talking about the auto class now when I hit base dot. Okay? And I can access all of its members. So base dot start. Now, let's run it and see what happens. So we get starting, which was the base class's implementation of the start method, and then truck ignition sequence, which we printed out from the truck classes derived implementation or overridden implementation of the base classes implementation. Okay, hopefully that made sense. All right, so that wraps up overriding a base class's implementation of a given method. The same thing works for properties as well. I'm not going to show you that. But this is not something that you can just say, oh, that looks interesting, and forget about. This is a concept that you have to know. So please, if the previous video and this video don't make complete sense, and you can just take them at their face value, but they have to make sense, then you need to rewatch those videos, okay? So assuming that you got that, it's sinking in, great. We'll see you in the next video. Thank you.